Okay, let's look at the homework 14, problem number 6. Right, so we want to rewrite this double integral in polar coordinates and then evaluate. Right, so I'll help you set it up. Right. Right, so first thing is we have to know the region. This is actually fairly easy to see. Right, so x is going from 0 to infinity. Right, and y is goes from 0 to infinity. So which means that we're talking about the first quadrant. Right, so maybe I'll sketch the picture. All right, so you have an x-axis. Oops, sorry. So x-axis, right, so something like that, and the y-axis, right. So just the first quadrant, so y-axis, origin, and here's the x-axis, right. So we are talking about x goes from 0 to infinity, y goes to 0 to infinity. So we are talking about the first quadrant, which is this region right here, right? And this just keeps on going, right? So, all right, so this is the region we're looking at, right? Then we want to use polar coordinates. So this integral can be rewritten as, right, it's still going to be a double integral, right, then we have to rewrite this. Remember, x squared plus y squared would be r squared, and then square root, so it's going to be just going to be r, so it's going to be e to the negative r. All right, then the area element for the polar coordinates would be r dr d theta. So we have r dr d theta. All right, then this region, so 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 for fixed theta, right, so if you fix theta, then r is going to be just a ray from the origin, right? Right, for fixed the angle theta here, so we have to have a ray starting from the origin, right? Which means that the r is going to be 0. So here, r is going to be 0, and this is going to, r is heading to infinity, right? So here we can do r equals 0, right, to infinity. Actually, maybe I should use the blue. How about that? So r value start from 0, then go to infinity, right? Then so you have one ray taken care of. So to swipe the whole first quadrant, you would have to start from angle 0, right? So theta is going to be 0 there, right? That's theta, right? Which looks like this, right? So you have a ray, so that's a positive x-axis, right? So that's 0 there, right? Then you keep on doing that, so you have increasing theta. You have a bunch of rays going like this, right? And a ray here, and you can see that theta needs to go to 90 degrees or pi over 2, which is a positive y-axis, which looks kind of like this, right? So you have a whole bunch of rays, but theta needs to go from theta equal to, maybe I have here theta equal to 0, all the way to theta equals pi over 2, right? So this is going to be just pi over 2, right? That will cover the same region, and this is the same function in polar coordinates, right? Right, that's it. I'll let you you know, compute that, and I think you're gonna need to use integration by parts to do this integration right there. All right, so I'll let you do that. All right, that's it. I hope that this will get you going.